Determine for the function f of x equals x cubed minus 2x squared minus 5x over the absolute value of x squared minus x for x is less than 0, negative 5 for x equals 0, and the absolute value of x squared minus 5x over x squared plus x for x is greater than 0 at the x-coordinate x equals 0, whether it is parts a through e. Each of the parts here involves the continuity of the function, so the first thing to do is write down the definition of what it means to be continuous. And that'll be limit as x approaches a from both sides of f of x equals f of a. Specific to this problem, we're looking at the x-coordinate of 0, so we can write this down as limit as x approaches 0 from both sides of f of x equals f of 0. We don't know if this is true yet or not, so we can put a question mark above it. If it is true, it will be continuous. To determine this, let's start with the two-sided limit. Limit is x approaches 0 from both sides of f of x. F of x here is a split expression function, and it's splitting right at the x-coordinate of 0. Therefore, to work out the two-sided limit at 0, we have to work out the two one-sided limits separately from each other. So we have the limit as x approaches 0 from the left side of f of x, and we have the limit as x approaches 0 from the right side of f of x. Let's start with the left side limit. The left side limit means less than 0, and from the split expression function, that means we will use that expression for f of x. So we can now replace f of x with x cubed minus 2x squared minus 5x over the absolute value of x squared minus x. First thing to do is try putting a 0 in front of each of the x's. That'll give us 0 cubed minus 2 times 0 squared minus 5 times 0 all over the absolute value of 0 squared minus 0. 0 cubed is 0, minus 2 times 0 squared is 0, and then minus 5 times 0 is 0, over the absolute value of 0 squared, which is 0 minus 0. 0 minus 0 is 0, so we end up with the 0 over the absolute value of 0. Since we have a 0 on the absolute value symbols, we have to look closer at the side we're coming from. But before we can do that, we need to factor the numerator and denominator. The numerator has a common factor of x, and it is that factor of x that's making 0 in the numerator. That'll leave us with x squared minus 2x minus 5. In the denominator, we also have a common factor of x within the absolute value, and that will leave us with x minus 1. In the denominator, we have an absolute value of a product, and it can be broken up into a product of absolute values. The absolute value of x times the absolute value of x minus 1. We have x approaching 0 here from the left. That means we're less than 0, which means we're a negative number. And when we plug in a negative number for x, the absolute value that's making a 0, which is the absolute value of x, as x goes to 0, that x will be a negative number. And the absolute value of a negative number will become a positive number. And that means that absolute value of x for the left side of 0 can be replaced with removing the absolute value symbols and putting parentheses, and we will need a negative out in front because the absolute value ensures a positive, and the double negative will make a positive. X is a negative number here by being on the left side of 0. The absolute value of x minus 1 we'll leave alone because that's not making a 0 in the absolute value. We will leave the numerator alone. Those x's can now cancel. leaving us with x squared minus 2x minus 5 over negative times the absolute value of x minus 1. Since we canceled the x's out, we should no longer have the 0 over 0 indeterminate form. We can retry plugging a 0 in for each of the x's. That will give us 0 squared minus 2 times 0 minus 5 all over negative absolute value of 0 minus 1. In the numerator, 0 squared is 0, minus 2 times 0 is 0, and then minus 5. And the denominator, we have the negative of the absolute value of 0 minus 1, which is a negative 1. In the numerator, 0 minus 0 minus 5 is a negative 5. In the denominator, we'll have negative of the absolute value of negative 1 is positive 1, but that negative is outside of it. Negative 5 over negative 1 is a positive 5. Now we can look at the right-sided limit. And the right side of 0 means greater than 0. Up here it's a split expression function. That means we'll use that expression. We have limit as x approaches 0 from the right side of, we can replace f of x with the absolute value of x squared minus 5x over x squared plus x. If we try plugging a 0 in here, it will give us the absolute value of 0 squared minus 5 times 0 over 0 squared plus 0. 0 squared is 0, minus 5 times 0 is 0. And the absolute value over 0 squared is 0 plus 0. 0 minus 0 is 0. So the absolute value is 0 over 0 plus 0 is 0. Since we have a 0 within the absolute values, we have to look closer at what side we're approaching from. Before we can do that, we will need to factor the numerator and denominator. The numerator has a common factor of x that will factor out. It will stay inside the absolute value. And that will leave us with x minus 5. And in the denominator, we have a common factor also of x that will factor out. That will leave us with x plus 1. In the numerator, we have the absolute value of a product, and that can be broken up into the product of absolute values. Separate each of those into their own absolute value. And the reason we do this is we want to identify the absolute value of what's making 0 inside the absolute value, and that's going to be this absolute value of x. As x goes to 0, that'll be the 0. We're approaching 0 from the right side, and the right side of 0 means greater than 0, means a positive number, so x will be a positive number. Since it's already positive, the absolute value will not change its sign. It will keep it positive, and therefore the absolute value symbols can be removed and replaced with parentheses with a plus. The absolute value of x minus 5 is not going to be a 0 in the absolute value, and therefore we retain those. The x's can now cancel, which removes the 0 over 0 indeterminate form. And so we have left limit as x goes to 0 from the right side, positive absolute value of x minus 5 over x plus 1. We can now retry plugging a 0 in for each of the x's. It should no longer be the 0 over 0 indeterminate form. And we have the positive absolute value of 0 minus 5 over 0 plus 1, or the positive absolute value of 0 minus 5 is a negative 5 over 0 plus 1, which is a 1. The absolute value of negative 5 is positive 5. Times that positive is still positive 5. We have positive 5 over 1 and 5 over 1 is a 5. To determine the two-sided limits, we compare the results of the two-sided limits, and they match. They're both a 5. So the two-sided limit is therefore a 5. The next thing to do is look at f of 0. F of 0 means to look at the function right at x equals 0. Up here at the split expression function at x equals 0, f of x is a negative 5, and that means f of 0 equals to negative 5. To recap our results here, we have the limit as x approaches 0 from the left side of f of x does equal the limit as x approaches 0 from the right side of f of x. And therefore the two-sided limit does exist and equals that number as well. But these do not equal f of 0. And this is the exact situation where we have what is called a removable discontinuity. And we have situation B. It is removable discontinuous.